Alright, hello once again. This is Jeff Scott of Rankin Technical College. And I've been going over the PowerPoint presentations along with some code for Murock's Android Programming 2nd edition by Joel Murock for the AWD1112 or 1112 Java programming class. And in the last chapter, in chapter 8, we were sort of, towards the end of the chapter, we were introduced, let's see, at the very end, a little bit, we were introduced to the idea of fragments. Well, fragments are the idea behind this chapter. I don't know if it'll take one lecture or two, but Android introduced fragments back in version 3.0, which was API 11. So they're available for most modern Android devices. You use fragments to create user interfaces so you can have different user interfaces for small screens versus large screens, or for example, landscape versus portrait, etc. So we have 7 applied objectives and 5 knowledge objectives. So those objectives in turn for the applied are create a fragment and display it in an activity, create a preference fragment and display it in an activity, use 2 or more fragments in a single pane layout for devices that have small screens, use 2 or more fragments in a multi-pane layout for devices with large screens, detect the screen size and display an appropriate single page or multi-pane layout, control when the soft keyboard is displayed and the action button that's displayed, and use Java code to replace one fragment with another. Those are our 7 applied objectives. For knowledge objectives, describe how you can use fragments in a single pane or multi-pane layout, compare the lifecycle methods of a fragment to the lifecycle methods of an activity, describe when the onCreate view and the onDestroy view methods of a fragment are called, describe how an alias for a layout can help you create multi-pane layouts, and finally describe how the smallest width qualifier allows you to detect screen size. So again, a fragment is a class that you can use to define part of a user interface. Then you can use an activity to display 1 or more fragments at a time. So fragments in this context are sometimes also referred to as panes, like a window pane. On a small screen, an activity typically displays in a single fragment. All right, and it's known as a single page or pane layout. So in what you see on your screen, this is from figure 9-1 on page 261, the tip calculator activity displays the tip calculator fragment, and the settings activity displays the settings fragment. At this point, the app looks and acts as if it were not using fragments. However, if you were to work on a large screen, you might want to do this, where you can have an activity that can display multiple fragments at the same time. This is known as a multi-pane layout. In this example, a large screen is shown, so there would be the large screen in portrait orientation, and there's the large screen in landscape orientation. And in this case, the activity displays both the tip calculator fragment and the settings fragment. As you can see here, in landscape orientation, you've got the tip calculator fragment on the left-hand side of the screen, and you've got the settings fragment on the right-hand side of the screen. On the other hand, when we look at this in portrait mode, the tip calculator fragment is at the top of the screen, and the settings fragment is below the tip calculator fragment. In either case, both fragments, both portrait and landscape, are immediately available to the user. So again, you can use a fragment to define part of the user interface for an activity. A fragment is sometimes referred to as a pane. On a small screen, like a phone, an activity typically displays just a single fragment known as a single pane layout, whereas on a large screen, where typically would be on a tablet, an activity can display multiple fragments known as a multi-pane layout. Fragments can be also reused in multiple activities. So let's look at the life cycle of a fragment. First, as it says here, you use a fragment to define part of a user interface. We already looked at that. We've actually already looked at all of this. So here is the life cycles, I guess, of a fragment. The fragment class defines methods that are called by the Android operating system at different points in the life cycle of an activity. This is what's shown in the diagram. This is replicated from the diagram on page figure 9-2 on page 263 in the book. Most of these methods are similar to the life cycle methods of an activity. For example, like an activity, a fragment includes an onCreate, an onPause, and an onResume method. The life cycle of the activity that contains the fragment affects the life cycle of the fragment. In other words, when Android calls a lifecycle method for an activity, it also calls a similar lifecycle method for each fragment that's within that activity. So again, a fragment has lifecycle methods that are similar to, but not identical to, the lifecycle methods of an activity. On figure 9.3 on page 265, it shows how to create the layout for a fragment. All right. So first we're going to talk about a single pane layout. Remember, with a single pane layout, it's useful for a small screen device such as a phone. Since many devices have small screens, you often begin by creating a single pane layout. Once you have that working, you can add multiple panes layouts for devices that have larger screens later by just kind of adding on to it. So the figure shows how to create the layout for a fragment. To start, the XML code for the fragment works the same as the XML code for an activity. As a result, if you want to convert an existing layout for an activity to a fragment, you can just rename the XML file. Then you can use the graphical editor to work with the layout of the fragment, just as you can use the graphical editor to work with the layout for an activity. In the case here, the graphical editor shows the layout for the tip calculator fragment. Figure 9.4 which is on page 267, and the beginning of it is shown here on the slide. It shows how to create the class for a fragment. In general, the class works a lot like an activity class. However, there are a few differences. To start with, the class for a fragment extends fragment rather than activity. Next, within the class for the fragment, the onCreate method typically initializes components of the fragment that aren't related to the layout for the user interface. So we've got this set has options menu, and it has a bool passed in. Set to true to indicate that this fragment has an options menu and would like to participate in populating the activities option menu by having Android call this fragment's onCreate options menu method. The onCreate view, or the onCreate method that you see right here, is typically again used to initialize components of the fragment that aren't related to the layout for the user interface. The onCreate view typically contains code that's used to create and initialize the layout for the fragment. Within this method, it's going to do things like inflate to return a view object for the layout, etc. Now, if you do need to convert an existing activity to a fragment, you can usually start by cutting code from the activity class and passing it to the fragment class. Figure 9.5, the beginning of which you see on your screen right now, and on page 269 of the text, shows how to display a fragment in an activity. To start, you can create an XML file that contains the layout for the activity. Here it's named activity_main.xml. And after creating the XML file, you can use the activity class to display the layout as shown right here. Figure 9.6, which is shown on page 271, shows how to create a fragment that displays preferences. The first code example, the one that you see on your screen right here, shows a fragment named settings fragment that inherits the preference fragment class. Pretty much the same code as what we saw in the settings fragment in the previous chapter. Once you created a preference fragment like the one shown, it's easy to display it in an activity. To do this, you can define a layout for the activity that uses the fragment element to display the fragment as shown here. Then you can define an activity class that displays the layout as shown pretty much here. On pages 272 and 273, figure 9-7 says you're now ready to work and look at and use a multi-pane layout. Again, commonly used for devices with large screens, such as, all right, but not maybe limited to, but basically tablets. So figure 9.7, the beginning of which is shown on the screen here, shows how to add multiple fragments to a layout. To do that, you can add 2 or more fragment elements to a layout file. The first example that's here is designed to display 2 fragments when the section or screen is in landscape mode. And the next one shows how to do it in portrait mode. Now on 274 and 275 in figure 9.8, the author discusses how to detect screen width. When the tip calculator app starts, it launches the tip calculator activity, which displays the activity main layout that's in the layout directory. However, for large screens, you may also want to display one of the 2 pane layouts of the previous figure. You can do that by detecting you can detect large screens by creating a values directory and including a smallest width qualifier like what's shown here. So again, for devices with small screens, Android uses a layout in the layout directory. To detect large screens, you can create a values directory that uses the smallest width identifier. To detect landscape and portrait orientations, you can create a values directory that uses the land or port qualifiers. Within a values directory, you can use an alias to point to a layout file that's stored in a layout directory. This provides a way to avoid duplicating code in multiple layout files. You want to specify an alias for a layout, you code an item element. Then you set its name attribute to the name of the layout you want to replace. The smallest width qualifier was introduced in Android 3.2 or API 13. So it's again available on most modern Android devices. With Android Studio, you can create a layout.xml file and its directory by right-clicking on the values directory, selecting the new values resource, and using the resulting dialog to enter the name for the file and directory. All right. In Figure 9.9, the beginning of which you see on the screen right here, and also on pages 276 and 277, the edit text element contains a request focus element. As a result, when the app starts on a device with a large screen, Android moves the focus into this edit text widget. Then if there is enough room, Android displays the soft keyboard for that edit text widget. If this isn't what you want, you can delete the request focus elements. A common problem is that Android doesn't always display the context action button on the soft keyboard. If you need to fix this, you can use the IME options attribute of an edit text element to specify the correct action button for the soft keyboard. So again, if you don't want Android to display the soft keyboard when the app starts, you can delete the request focus element from the body of the edit text element. If Android does not display the correct action button on the soft keyboard, you can use the IME options menu of the edit text element to specify the correct action button on the soft keyboard. So far, this chapter has presented skills that you typically need for working with fragments, but in some situations, you may need skills presented next to work with fragments, such as in Figure 9.10 on pages 278 and 279, the author discusses how to get a reference to a fragment object. Once you have a reference to that kind of object, you can call any of its public methods. Or if you cannot get a reference, you can take the appropriate action, such as displaying a menu. So you can use the fragment manager object to get a reference to a fragment object. Again, this returns a fragment manager object. The find fragment by ID returns a fragment object for the fragment with a specified ID. If it does not exist, it returns null. Some code examples. And finally, on pages 280 and 281, Figure 911 on page 281 shows how to use Java code to replace the content of a container with a fragment. Here the fragment named settings fragment replaces any other fragments that might be in the content container for the activity. To do that, the code uses the getFragmentManager that we saw previously to get a fragment manager object. All right. The code that you see here accomplishes the same task as the code shown earlier in Figure 9.6 on pages 270 and 271. So which way is better? The author says, again, this is largely a matter of personal choice. The author will use the first one because he thinks that the XML is easier to understand. All right, so the skills presented in this chapter get you started with fragments. Android apps can use fragments in many ways. As we progress through the book, we'll see other examples. Now, I just want to mention one more thing, and that is that when I come in here tomorrow, I'm done lecturing for a while, but when I come in here tomorrow, I'm going to go over chapters 10, 11, and 12. That is a news reader app. I am not going to write any code. Rather, I'm going to bring up the associated code and talk about it within the guise of talking about the also the PowerPoint presentations. So this will be 10, 11, and 12. Chapter 12 is very short. Chapter 11 is quite long. And chapter 10 is also quite long. All right, so when I return tomorrow, I will be going over the code for that section, but not in a lot of detail. All right, once we get to the next section of the book, okay, we're about to get into section 3 on the newsreader app, but once we get to section 4 on the to-do list, we'll look at the code in a lot more depth and breadth of coverage.